We're recording. Good. Yeah. All right. I'll back up a moment so that those people that there are a few people that are missing this will want to listen to it later. This was the night before the conjunction of Venus and Mars. And I've just looked at it for the first time here. Okay. Well, since I wasn't prepared for a mini lecture on this, we won't go into opposition and the opposite of that, which I'm forgetting the word right now. Any kind of planet sometimes can be like Venus and Mercury, which isn't shown. Sometimes they appear between us and the sun, and sometimes on the far side, which is why Mars sometimes is fairly faint, and it's the same with Venus, waxes and wanes in brightness. In this particular case, you can see how they were lined up from our point of view, so that they appeared to be on top of one another. Any questions on that before we give Jordan his due? He's worked long, hard hours on his experiment, partly because one of my sentences wasn't accurate. And both he and I, unbeknownst to each other, in thinking about it, scratched our heads and said, well, that's not working right. What's going on? And then he spent a whole day and a half, most of the night before our meeting 2 weeks ago, trying to figure it out, looking things up. And he finally found the answer, but I'm going to let Jordan tell you what he did and what his results were. Jordan, you ready?
Yeah.
Okay. And just a reminder, speak slowly, because sometimes you get excited and carried away, and then we lose the words. All right?
Okay.
Jordan, I'm just going to pull up a picture and you can tell us what it is, okay?
Okay.
Okay.
Maybe, Jordan, you have to, some people weren't here then and don't know what you did. So maybe you first have to tell them what you were doing.
Okay. So my assignment or task was to demonstrate what it looked like for the orbit of Uranus, because it has a different type of, it spins differently than other planets. So I needed to demonstrate how the seasons were different and how it orbited around the sun. So what I did was I used an orange for the planet, and then I used that light to shine onto it. So the way that Uranus works is it spins on its equator. So it's at a 98 degrees. So it's basically just sideways.
88 degrees, Jordan. 90 would be straight up.
I've seen 98 also.
Oh, really?
Yeah.
Oh. Well, we're going to go with 88.
Okay, so it's at 88 on its side, and it spins on its side. So originally, when I was doing this, she asked me to roll it on its side around the sun. So I did this the first time, and you can see there, it's one of the poles is facing the sun. So I did is I rolled it around in a circle, and I took pictures of it at each of the like at 4 angles, when it's at 4 different points at an equal distance around the sun.
So Jordan, for us, that would be like our 4 seasons.
Yeah.
Yeah, right. Okay.
So when I rolled it around the first time, I was like, okay, so this is how it would look. So I have 3 other pictures, but the first time I did it, it was wrong because I rolled it around and the pole was always facing the sun. But when I looked up information about it after, it was mentioned that the planet Uranus, for 42 years, one pole or one side is in the sun, and then it will switch after 42 years, halfway through its orbit, and the other side will be basically sunlight for the next 42 years. So I didn't really understand how this worked, because when you're rolling it around, one pole always faces the sun. But the way that it works is Uranus spins, but it always stays in the same orientation to the sun. So you can see on this picture compared to the previous one, in the first one, the pole was facing the sun. but then as it moves around, the sun will be pointing at its side.
Mhm.
So the other side of the planet will be in the dark. I don't think it's as completely accurate as how the sun looks on it, because I think that it needed to be farther away, but I didn't have strong enough light to simulate it completely accurately because of the distance. It should be darker on the other side. But as it's going around, so on the next picture, which it would be the opposite pole from the first picture, will be facing where the sun would be.
Okay.
Let me see if I can pull that
Hang
one up.
on, we're catching up. Jordan, let me just interrupt here and correct one thing. Uranus takes 84 years to go around its orbit. And the original problem was it seemed that the one pole, let's call it the North Pole, always was facing the sun. Well, that's not
Yeah.
correct. Think of our Earth with its tilted axis. Our North Pole always points, at least, in 1,000 years time frame, to the North Star, the pole star. And the same is true with Uranus. You have to go way out in space somewhere, and somewhere out there, there's a star that the pole is pointing at. So it's not pointing at our sun, but rather some distant star. So what happens as it goes around in 84 years, let's start arbitrarily with the North Pole, its North Pole facing our sun. And then as it's turning on its equator, which happens to be sideways, you will have a fourth of that quote year, or roughly 21 years, our time, of daylight the whole time, summer. Then it rolls a quarter way around the orbit, and now the equator is facing our sun. So since it's rolling around the equator, so to speak, you have day and night, 50-50. And since it spins faster than we do, I think it's roughly 8 hours of daylight, 8 hours of darkness, 8 hours of daylight, 8 of dark for 21 years. And then it's around the other side, halfway around, and the South Pole is facing the sun all day long for 21 years. And then we're back to the last quarter of the orbit. And once again, it's on its side, and we're having day, night, day, night. So according to Earth, it's very weird, is it not? But for Uranus, that's what it knows. Okay, so back to you, Jordan.
Those were the main points. I think you covered the other part with it being in quarters. The other thing that I had, when I originally sent these, I had titled them based on the equinoxes.
Mhm.
That's lost in the certain one. I think that one will be. I'm not sure. The years for it though. I think the next one will be in 2028.
Oh, in
Will
our
be
own
the
year.
next time that it will be from one of the where I took pictures of it, and that would be it would be facing one of the sides.
All right.
I think the left side.
And I suddenly realized, revealing my age, I'm almost, not quite, but getting there, almost as old as 1 year in Uranus. So in a normal lifetime here in America, where many people live into their 70s and 80s these days, didn't used to be true, but it is now, the time it takes Uranus to move through our zodiac is about one lifetime, which I think is kind of interesting. So that might be an assignment everybody would enjoy doing. Whatever your birthday was, where was Uranus in our night skies compared to the zodiac? Because in 84 years, it moves through our zodiac once. Duh. Yeah,
So can I ask just a couple of questions?
Sure.
So summer would last 21 years.
yeah. And
Each
the-
season would last 21 years,
well,
roughly.
well, they only really have two seasons, winter, winter
and
and
summer.
summer. And the two other ones of 21 years are sort of like us, except the day and night are 8 hours each, 16 hours long. Because at that point, it's rolling, the sun is still in the middle, but it's rolling this way on its around
Right,
its axis.
okay.
So the circumference is going around and around and around.
I don't really understand. Doesn't this happen gradually?
Yes.
I
But
mean,
well, I think yes, it does. Very good, Sandy. But I think what the astronomers are doing are kind of simplifying things.
Mhm.
But you're right, it would go gradually from one to the other,
Mhm.
just like our now, as my old friend John used to say, once we are past the summer solstice,
Mhm.
the days are getting shorter and the nights are getting longer, but it doesn't happen bang. Very good, Sandy. Any more questions? Or Jordan, you have any more comments?
No, that was the main things that I found about it.
Okay, I'm just gonna interpose here. Maybe you didn't have time. We talked last night on the phone. Triton, the largest moon
Oh.
of Neptune.
I think, Mary Lou, do you have a question?
Mary Lou,
Mary Lou, you're muted.
can't hear you.
Okay, you
There we
wanted
go.
us to tell you where Uranus was on our, I don't know if it's this year on our birthday or the day we were born.
Oh, the day you were born.
And how do you find that out?
Google it. Position in the zodiac of Uranus on whatever the date is, the year,
Okay.
the year.
Okay.
I would guess. That's how I would try.
Okay. Thank you.
You're welcome. Any more questions before we get to Jordan's new, which he may not have done yet? Okay, Jordan, did you find out any information about the largest moon on Neptune, which is named, why can't I remember it?
Triton.
Triton, thank you.
I haven't found that much yet. I do know it's the 7th largest moon in the solar system, though.
Okay, I tell you what, sometime in the winter, we're gonna go through the planets one by one. And so let's keep that curiosity until we talk about Neptune, okay? So you
Okay.
have plenty of time to research it. All right, oh my. We need to get to today's, before we run out of time. Let me see where we are. Okay, Jordan, before you disappear, I think on the phone last night, I asked you about Hercules. Is that true?
Yeah,
Okay, have you had a chance?
and M13.
And M13. Have you had a chance to look them up or not?
A little bit.
Okay, what did you learn? Did you learn about Hercules, a constellation's nickname?
I did not find a nickname. I'm not sure like what name I'm looking for.
Well, right. I would call it Hercules nickname or common name or other name. But does anybody out there happen to know what it is?
Is it part of a larger constellation?
No, it's an asterism within Hercules, which is
Oh,
the
okay.
large constellation. Well, I'll toss it out. It's called the Keystone constellation.
Oh, that was the one. I did see that, but I didn't know
Oh,
that
you
was
did.
what I was looking
Okay,
for.
now,
when I looked it up, the keystone was just the four
Part-
middle stars.
yes, the four
Yeah.
stars. And now,
Yeah.
Sandy, I think you joined us late from February. We talked about asterisms early on in the program.
Mhm.
An asterism is a real obvious pattern, usually within a constellation. Once in a while, it's part of two constellations. And once in a while, it's just sitting out there. Well, no, it can't sit by itself because we've chopped up the sky into constellations. So for instance, the Big Dipper is an asterism of the Great Bear. So the keystone would be an asterism in Hercules, and it looks like a keystone. Does anybody, this is a pottery town, somebody should know. Does anybody know why that particular shape in the middle of Hercules is called the keystone? Or any architect? Okay. If you're going to build a Roman arch, you first have to build a wooden frame, and then you start laying the stone blocks from end to end, up and up, curving in, up and up. You get to the very top and you place, I don't know if, can you see my hands, or can we have an image of Hercules online? You place a stone that's not quite a rectangle. It's a little fatter at the top and a little thinner on the bottom. And you put that keystone in the arch. You take away the wooden frame and gravity goes and everything settles, and the keystone keeps it from collapsing. It's in the center. Now, from
they
our
can't see it
view,
yet.
it's upside down. No, it's not upside down. I'm sorry, it's right. It's
I can't
correct.
see it yet.
Yeah, oh, that's good. Can they see that yet?
Not yet. Hold
Okay.
on.
It looks
It's
like a keystone.
Yes,
can
which
see
is
it?
why, now, why is the state of Pennsylvania's nickname the Keystone State?
It's kind of that shape.
No, it's not that shape. Think back to colonial times when we had 13 colonies. Pennsylvania was Philadelphia. Now,
Oh, yeah.
wasn't Philadelphia, Jordan, you're better at history than
Wasn't it
me.
briefly the capital?
It was briefly the capital, and Pennsylvania was
Yeah.
kind of in the middle of that
Mhm.
string of colonies. So anyway, there is Hercules. Now, I must admit, I'm not that familiar with Hercules. Leave this map up, because I can't bend my head. It looks straight up in the sky, and pretty much at this time of the year in the summer, it's pretty much straight overhead. A little to the west, if you were looking south, which is what this view is doing. Oh, very good. Leave this up, this we're gonna need this.
I see the.
To the left, to the east, is Vega, the brightest star in the sun, just about the brightest star in the summer sky. Okay. And did you find out, we don't, okay, I'm gonna, how can you highlight this, Melanie? Halfway up the right side is where a little way up, yeah, right about there is M13. Jordan, did you find out what that was?
It's a Messier.
It's one of
I think
Messier's.
that's what the M is Messier, so it's Messier 13,
Mhm.
and Hercules is a part of it.
Okay,
I think it was cataloged in 1764 by Messier.
yeah. We'll review that in a little bit if we have time about Messier. Once again, some people way back in the beginning missed those talks. Did you find out that it was a globular cluster?
Yeah,
No,
the Hercules globular cluster.
right. And did you research what that meant? What kind of cluster is a globular cluster?
I did not find out what.
Okay, once
That
again,
is.
guys,
It's a whole bunch of like 1,000 stars, right?
yes, we're gonna hang on to this because I need to get through the questions from everybody. And then we'll have time in the middle, I hope, to talk about the difference between a globular cluster and something we looked at, Rima checked them out, open clusters, different.
Oh.
Okay. Very quickly, I don't know how to pronounce it. The very brightest star down at the bottom, the foot, if you want to say, that's the Alpha star, the brightest in this fairly dim constellation. However you pronounce
You
it.
asked me to look that
Okay,
up.
what colors are it?
Rough. It's Razzle Geesey is what I call it.
Okay,
Yeah, that's what they said anyway. And you wanted me to find out, I guess it's a double star.
yes, it's a double star. And what,
And in some places it says it's red, but then they think
Really?
that maybe one of
Huh.
the stars is actually it's been variously white or bluish turquoise or whatever.
all right.
So
We'll have
green.
we'll have a chance to prove, at least from our visual point of view, because when we have our next star party sometime next month, Melanie was going to bring her telescope and we'll be able to split the double star. According to my research, it's blue and blue-green. Or maybe, well, we'll double check that. I'm going to take
You-
a parentheses
Mr.
around
Chair?
that. Pardon? Yes, Mary Lou.
Last time you said it was orange and blue-green.
Okay, thank you. Thank you.
That's what it is at this site that I'm looking
Okay.
at. The
In
Webb
re-
Deep Sky Society.
In redoing my notes, this is why when you study the Bible, and it was the monks back in the day, all by hand, would copy a text. And then 100 years later, somebody else would copy the text. And it's like the game of whisper secrets. And I forgot to put the orange in my colors. So yes, one is orange-ish and one is blue-greenish. And we'll probably be able to see it with the telescope. I'm excited.
Nice.
Okay, we got to move on. Can we? All righty. Oops, there's an answer. Who did I assign this to? Bob and Ann. And it was about the northern crown, which is here to the right of Hercules. You see that circle of stars with the bright one named Gemma right there. Okay, Bob, Ann, what did you, I assigned, I forget who. Who did I assign our nickname for Corona Borealis? Bob, was that you?
Well, I remember looking for the nickname of Corona Australis.
Oh,
But
that's the
the
southern one.
southern.
really?
See, I got a little Wikipedia page here, and it
Shoot, that's
the
wrong.
blaze star. Yeah, it says the Corona Borealis is also known as the blaze star.
Okay, but there's an Australian nickname for it. We call the Corona Borealis the Northern Crown because I think there is a southern crown. But I meant this
I
one.
know what it is.
What's
It's the
that?
boomerang.
Who said that?
The boomerang. Regina.
Regina, hiya. You're not sitting out
Hi.
here by the back door.
No, it's too hot over there in the lawn. Guy was mowing the lawn.
That's
So
true.
I'm
I
across
heard
the
them.
street in the park, and in Australia, the Corona Borealis is known as Woomera, the boomerang.
Well, you see why I signed that to Bob because he spends time down in New Zealand and I thought he'd get a kick out of that. But I'm glad somebody found it. Thank you.
Yeah,
We
and
definitely-
other countries have names for it, different names.
Right. It's a fairly, I think all the stars are magnitude 3 and maybe Gemma is 2. I can't remember exactly, but they're not that bright. And you need a clear night and a good neck to bend because at this time of the year, it's pretty much straight overhead at 10, 11 at night.
Mary Lou,
Yes.
what I got here says the brightest star, this is the Corona Borealis.
Yes.
The star is magnitude 2.2 Alpha
Okay.
Coriolis Borealis.
Yes. So
No,
that's okay. That'd be Gemma. And yes, okay, it's a 2. The rest are kind of 3 then, I think. And so once again, but it's easy to spot. It's a nice little circle, almost a circle. It's not quite fully rounded. And it's sitting there just to the west, to the right, if you're looking up facing south of Hercules. So,
North American Indians called this constellation the Camp Circle because
neat.
its shape was similar to the way they arranged their camps in a semicircle.
all right.
Oh, neat.
You know what we can do maybe for next time? We're going to mention the Milky Way next time, and lots of cultures around the world have all sorts of interesting but different names for the Milky Way. And maybe everybody could do that for fun. All right. Alrighty, my next question had to do with Scorpio. So Scorpio is going to be to the right here and find a new star map. And I wanted somebody, was it?
It was Mary Lou.
It was you, yes, to
Yeah.
find the Alpha star, meaning the brightest star in Scorpio. What is its name and what is its color?
The name is Antares and it is red. And the
And
name means rival of Mars.
yes, and I think way back on our first assignment was the question, how, if they're both reddish, Antares and Mars, how do they make that red light? And does anybody remember the answer to that, since you brought it up, Mary Lou?
Well, I know red means a cooler star,
A what star?
a cooler.
Yes, as a matter of fact, several of our big red stars, like Betelgeuse in the winter and Antares in the summer, are red supergiants getting ready to blow up.
Yeah.
And who knows? Maybe like 1054, and you walk out one night, 1,000 years later, and look up and boom. But anyway, probably not in our lifetime. And how does Mars appear red to us?
Because of its
Iron
iron
in the
oxide.
soil.
Right, the iron in the soil that reflects the sunlight, giving it a reddish cast. Now, Debbie, are you here? I haven't heard Debbie yet.
She's not.
She's not.
Let me double check.
Okay,
No, she's
no,
not.
okay. Fortunately, I have kept 7 of the many astronomy books I've bought over the years, and I've kept 7 as reference points. And every now and again, oops, M4, which is a globular cluster. Can we go back to the map of Scorpio? Now, this is a cluster that you can see with your naked eye if your eyes are good.
Oh, is
And-
it gonna show?
Well, that's okay.
M4?
We can point it out.
Okay.
Can you make that a bit larger though? Because we're going to look at a couple of these things here.
I don't think so.
Don't think
'cause
so.
It's part of a. no.
Okay.
Let me see if I can find a better one.
Yeah, she's going to find a better one. Anyway, I heard that in Scorpio, somewhere in my reading, was the cat's eye. And I thought at first, for some weird reason, I thought it was down in the curve, the sting. For some reason, I thought the 2 end stars were called the cat's eye, but that was not true. And then in one of my books, in researching information for this talk, it said M4 was the cat's eye. Let's see, what's the best? We're still hunting for a better.
Image, yeah, not really great.
We would need one with the open and clusters and whatnot, but we're just getting
Yeah.
just the stars, aren't we?
Maybe it's because I did Scorpio instead of Scorpius.
Scorpius constellation, Scorpius.
Oh. what's this one?
That'll do, I think. Yeah, can we enlarge that one? Okay, oh, that almost looks like one of my books that
Oh,
I
it's
have.
right near in.
There you go. There we go. Okay. Now, Scorpio is, I think, our biggest constellation, and it's in the summer sky, and it's fairly low on the southern horizon. As I look across my meadow to the south, this, where's your blinker here? The bottom curve there on the left is just above the tree lines. Now that means the lower you are looking towards the horizon, the more atmosphere you're looking through. So the hazier things tend to be. So it's a bit harder to see. But let's go up to Antares, the red eye of Scorpio, and squint, squint.
Oh, there's M4.
M4 is within the binocular. If you have regular old binoculars, nothing fancy, I believe you can see it in the same circle because it's that close. And it's bright enough. I think it's almost magnitude 5, which is about the limit of naked eye vision. And once you spot it with the binoculars, and if it's a clear night, you can see it with your naked eye, because I have. Now, it's a globular cluster like the one in Hercules, which means, well, I'll review it right now, because otherwise we probably won't get to it. What's our time, Melanie? What time is it?
1:35.
Okay. There are two types of clusters that we can see in our night sky. The ones like the Pleiades, and like what we're going to look at in a minute, M6 and M7, over to the upper left of the tail, are open clusters made of relatively young, new, bright, hot, often blue-white stars. And they form in the arms of the spiral Milky Way galaxy, where we are. The globular clusters have a very different history. They are absolutely ancient, 13, almost 14 billion years old, which means they came into creation around the time the solar system did, way back, way back. And they do not exist in the arms of the spiral solar system, the Milky Way galaxy. Picture this, guys. Remember what we looked at first with Venus and Mars and us and the sun, a diagram, flat, looking down from the top. Well, picture our galaxy out there in space, whirling around and around, and surrounding it like a big balloon, a big sphere, is where the globular clusters hang out. It's really quite fascinating, I think. And so this ancient group of stars, M4, is somewhere out there on that sphere surrounding the huge Milky Way galaxy. And the stars in it are, well, obviously very, very old. So we're going to, once again, in our star party, we're going to find not only Antares, the red eye of Scorpio, but M4. And then Rima looked up these little green lights up here. There you go. M6 and M7. Once again, old Messier back in Paris a couple of 100 years ago, he spotted those also and gave them numbers. Since Rima is busy, I'll tell you what she told me when I came in. And then remind me, Melanie, we got to go back to Cat's Eye. Okay. I got sidetracked. They are both open clusters, young stars in the arms of the spiral arms. And let me think, M6 was given the nickname the butterfly cluster because if you looked at it, once again, I use binoculars, we'll be able to see the way we visualize the cluster, it looks like two wings. So it was nicknamed the butterfly. And M7 was given old Ptolemy's name. Does anybody know who Ptolemy was and why a cluster would be named after him?
He was an early astronomer and he might have discovered it.
Okay, I don't know if he discovered it because he might have, but he was basically, he wasn't so much an astronomer, I don't believe himself. He was a great compiler of information. He lived in the 2nd century, somewhere in the 100 ADs, down in Egypt, in Alexandria, that wonderful city that had that wonderful library that we know who destroyed in the 400s. We won't mention their name, with all the valuable information lost. Anyway, he compiled several books, a few of which were saved, fortunately. And so there was a time when astronomers in Europe, anyway, when they were discovering things, they named some of the ancient astronomers, whether from Greece, once in a while, maybe from Babylonia. So M7, the Ptolemy open cluster,
Cat's eye.
pardon,
Cat's eye.
cat's eye, thank you. Let's go back to the cat's eye. We have not for sure discovered what's what here, but I have a theory from what Rima found online. And anybody that's curious can follow it up and see if they can find the answer. It turns out that M4, which is a globular cluster and nicknamed the cat's eye, also sometimes comes up as the cat's eye nebula. And we haven't talked yet about nebula, and we really won't until next time. But basically, a nebula is a huge cloud of gas and dust. Sometimes it's illuminated and we can see it, and sometimes it's just dark. So it's like smoke from a fire obscuring what's behind it. And Rima said the shape was like a cat's eye. That's why it was named that. And we all know cats can sit in a bright room with bright light, and their iris, which is iris, yes, iris, the dark part, starts out in a dim room, real round.
Yeah.
But unlike us, our iris, when we get into a dim room, just shrinks into a small circle. But theirs goes into this, what kind of a shape would you call that? A long, skinny,
Like a line.
like a line.
Yeah.
So I'm thinking between the globular cluster M up there by Antares has between, and remember it's way out there on the sphere surrounding the Milky Way galaxy. Between it and us, there must be a dark nebula shaped in a lens shaped, that's a good word. A long skinny lens shape, which gets in the way so that what we see looks like a cat's eye. Now that's my own
It
theory.
gives it that dark looking
And
line.
dark looking line
Okay.
down the middle.
Yeah.
That may not be the answer. So anyway, maybe somebody wants to do some research and find out what's going on up there. All right. We really don't have time for all this other stuff. I was going to review some things very quickly. No, I'm going to save it to next time because otherwise I won't have time to give out the questions. Okay. So next time we're going to review, for people who forgot or weren't here when we first went over it, that whole business of alpha stars, beta stars, etc. What's that mean? We'll quickly review magnitude again, what that meant. And I guess that's it. All righty, for next time, August 3rd. Oh my gosh, summer's halfway over. You ready? Well, Debbie's not here, so I'm going to have to call her up, and she's going to have to come up with what the Milky Way galaxy is, its shape, how big is it, how many stars are in it, and where it is in the sky. Okay. Jordan, you still here?
Yeah.
Okay. Somewhere there is the center of the Milky Way galaxy. And we can see it, the direction, from here on Earth. So you have to find out where should we look up into the summer sky to find, if we could see that bar, the center of the Milky Way galaxy. So where do we look and how far away is it? Okay? Where and how far? All righty. Mary Lou, you still here?
Yes.
Okay, we're going to be studying Sagittarius next time, which is the next constellation to the east left of Scorpio. M22, a cluster. I want to know what kind, where in Sagittarius do we find it, and what magnitude is it? So 3 things about M22, okay?
Yes.
All right. Sandy? Sandy?
Yes.
Okay. The Lagoon Nebula. So we're going to study nebulas. They're different than stars or clusters. Lagoon, Lagoon. find its number, the Messier number, find its magnitude, and where we would look for it in relationship to Sagittarius. And once again, on our star party in a month or so, we can spot this with our binoculars.
What is the name of this again?
Lagoon Nebula, Lagoon.
Okay, thank you.
All righty. Regina,
I won't be able to be here. I'm sorry.
okay, do you want to do the research anyway?
Sure.
Okay, and then you could telephone me and I can relate it. How's that?
Okay.
All right. I'm not sure how to pronounce it. Trifid Nebula, Trifid, the Trifid Nebula.
TRIF is in Frank.
Yes.
ID Trifid Nebula. Okay.
Mhm. And once again,
Got it.
what is its Messier number? And what is its magnitude? In other words, could we see it with our naked eye if we know where to look? And then, okay, and the third thing is, where do we look for it? Where is it up there? Near Sagittarius. Okay. Bob and Ann, you ready?
Go.
No.
Yeah, go ahead.
Okay. You can
Tell us.
divide this up however you want. What's the definition of a nebula? What's it made of? What's it look like? And then, this is one, this is maybe a little harder. Some of them are lit up, they shine. How does that happen? There's at least two different ways that a nebula can glow. So what are those two ways? Knowing Bob, he'll find a third.
We'll see.
Okay. Okay,
Uh, Mary
Debbie's,
Lou,
yeah,
I'm not 100% sure we'll be here.
okay,
Third, we got an appointment in Olean, but we might be back. There's a good chance we might be back. But in
All
any
right.
case, I'll get the answers to you.
okay. Or you can always tune in late. Debbie's not here, I guess. Well, I'll tell her she has to find the northern triangle. No, no.
You already gave her number one.
Okay, the southern, the summer triangle.
Now,
Right.
how big is the Milky Way?
Oh, that, right, okay. Who doesn't have a question? Melanie doesn't, all right. The summer triangle, what are the three bright stars that make up the summer triangle? And let me change my thing here. I made another mistake today, naughty. And while she's at it, since that's a fairly easy question, we'll have her also find Sagittarius for us so that when we start in, we can have it up on the screen.
Fair enough.
Okay, so. Oh, I know, I was gonna give that to Laura, but she didn't sign in today. Okay. What time is it? It must be close to
Is
time.
147.
All right, does anybody have any questions on this rather rambling presentation today?
Mary Lou,
Yeah,
this is Bob. Do you know if you can see the corona australis from the northern hemisphere?
I don't know.
They say it's the map we have. Let's see if I can read this. There's a little picture of it here, and it's sort of at minus 40 degrees. Can we see that far south?
I can't see anything right now. What are we looking for?
No, I'm not bringing it up online. I have it hard copy here.
Oh, okay, I don't have a copy, and we didn't make a copy for this month, did we, of the star chart? We
No.
don't have the star chart either here right now. I don't know. I do know that quite a few of the stars we see actually hang over the southern hemisphere. And they, of course, are
Right.
in our towards the southern horizon. But how far down we can see, I'm not sure off the top of my head. I should be able to figure that out, but My brain gets stuck.
We can't see the Southern Cross.
Right.
Where you go to Australia and New Zealand, the Southern Cross is very obvious. In
Yes.
fact, you don't even really have to know about it to suddenly see it up in the sky and say, gosh, that looks like a cross.
Yes.
Quite pronounced.
Sometimes later in the summer, when our summer triangle is setting late in the day, then sometimes it looks like a cross. Because once again, you know, things are seemingly on a sphere. And so as the night goes by and as the year goes by, their orientation to us shifts and they don't always look the same. I remember when I usually look at the stars, it's after dark in the evening. And usually they're coming up out of the east, or if it's later at night, they're to the south. But usually I'm in bed and asleep by the time they're setting in the west. I remember once, I think it was 2 years ago, and it was in the springtime, I think. And I don't know if it was midnight or whatever, but I glanced for some reason to the west and I saw this really bright light. And I thought, wow, is that a flying saucer? Oh, is that an airplane? What is that? And then after getting my binoculars out and trying to get my bearings, I realized, oh, it's Sirius setting. And of course, everything rises and sets, right? Rises, goes overhead and sets. But because I wasn't used to looking at it in that direction, to me, all of a sudden it became this strange object in the sky. So at one time, our swan, Deneb, becomes a cross as it's setting later in the season. Okay, any other questions that I can't answer? Do you want to ask them about doing emails for images or not? Or should we turn the thing off? Remember? Oh, but we're stopping the recording right now, and then we want to talk to you guys and ask you a question.